Now, in this session, we're going to talk about cross-contract calls. This is our day 8. And what we're particularly going to cover in this course or this session is going to be promises and callbacks. So we're going to combine the idea of promises and callbacks to be able to put in place or to establish a cross-contract call, right? Great. So let's do this. So let's look at this file. Now, the smart contract you're going, the source code, smart contract source code you're going to go through right now is going to serve as our external contract. Okay. So the contract we are going to call from the contract we are going to work on after this. Okay. So this is going to be the second contract we are going to call from the first contract. I hope I'm not confusing us. So I just want us to put this in place. Let me just edit everything right here. Great. So we just want to make this as simple as possible. So we have all that in place. Great. And now what we want to do is basically to implement a function that will be able to call from our other smart contract. Okay. So I'm going to give this name a very a function name you're going to be able to remember. Okay. So let's call this, let's do public function. Let's name it get address info. Then get address info is going to take self object as a immutable. Then we're going to have, is it going to, yes, it's going to take a parameter of type string. Let's call that message or MSG in short. Then this is going to basically return, let's return a tuple, or let's return a string. Let's make it quite simple. Let's return a string. So we're going to formulate a string and we're going to get the signer. Now, if you are keen on our, I think it should be our session before the one we had yesterday, where I was talking about the signer address and the predecessor wallet address. So those are the things we're going to make use right here. So the very first thing I'm going to do is get the signer address. Let me just bring in env. Then I'm going to make use of that down here. Signer account ID. Right. Then I'm going to get the predecessor. So like I said, the signer is whoever initiated that transaction in the first place. Predecessor is the immediate wallet address that is signing a transaction in a smart contract. So again, you're going to use env to get the predecessor. Hope that is the spelling. Account ID. Great. And now that we have the two, we now have the predecessor, sorry, the signer and the predecessor. We just want to make a string out of that. So let's construct a string. Let's name it result. This should be a variable. And we're going to do string from. And so we're going to say, so we're going to name these smart contract accounts. Smart contract, okay? We're going to give it the name account smart contract. So I'm basically going to initialize our string with the accounts, then a colon and space. Then over here, I'll do, let me just have this result as a mutable variable. Then right here, I'm going to do result dot push. And this case, we're going to push string. What am I writing? Push str. Great. So we want to push a string and we want to bring in our signer first of all. So we're going to do, let me see. Let's do signer address. If I can be able to do this first of all up here, let's keep then that. So signer address is going to be equal to our signer variable up here. Then I'm going to also construct the other one for the predecessor, and I'm going to say that, hey, our predecessor address was what we have right here. Sorry, what we have right there. Great. So that way we've been able to get the signer or whoever initiated that transaction in the first place, and the predecessor wallet address, whoever is initiating the immediate wallet address initiating this particular transaction in our smart contract. And down here, I'm simply going to return what? Result, right? So that should be able to go. So this one is saying mismatch type expected that, but then it found that. Okay. Dot as common str. So let me just make the change as well down there. Great. So this should be able to work. We should be able to go with this, but we're not making use of our message parameter. Okay. We can just make use of it because we are capturing it within our call. So let's just have it somewhere. So let's say call a message. So this is the message that we're going to accept as a parameter up here. So we're just going to bring it down here like that. Then our string will now be complete. So that is basically what we'll be returning back once this is invoked. Now, to make our work easier, or to make our life easier, let me just bring in our famous script folder and have it somewhere. Great. We are good to go. So the very first thing we're going to build, so let me just put our res folder in place. Great. Then I'm going to build that, then deploy. Now, to deploy this, let me first of all get to our settings. We're going to use c4 sankore.testnet. Then what we're going to create is accounts. Should be accounts, yes. Accounts.c4 sankore.testnet. Yeah, great. So now that we have all that, we have that in place, we're going to, let's head on to our deploy file. So the very first thing we're doing right here is deleting the sub account, then recreating it. Then let's specify amount right here and give it, so instead of the 100, the usual 100 default tokens that we usually send to an account, to a sub account whenever we create, since we're going to create more than one sub account. So I just want us to, minimize on the cost. So I'll just give this 20. Let's give it 20 near. 20 near is enough. All right. Then let's also change this right down here. And I'm going to do, let's change the name and name it accounts. Then bring this up in our deploy file and bring the update over there. Then you're going to try and call this. So I'll just do away with all these. For now, we're going to see all that after deploying it. So I don't know if you guys were able to see this. I think I just forgot to maximize my my window. Are you guys able to see it now? That's too much.
Yes.
Great.
Yeah,
So that is basically the function that we were trying to put in place. Now I'll just head on to my terminal. Then let's run these. Give the permissions first of all to our script files. That was successful. Then we're going to run our build script. Okay. We could be doing the call script as we wait for that. So we're basically going to test our get info function, right? So down here we can do near call. It's going to be a call function, or a change function in this case. So near call our sub account. Then the name of the function we want to call is going to be the get address. Great. So I think it compiled successfully. So let's proceed and deploy this to blockchain. See what that is going to give us as well. Oh, I think I saw an error. Oh, it should be initial balance. I think I was giving the wrong parameter right here. Initial balance should be that. So let's try this again. So what I'm going to do is I'm going to delete the grid sub account we've just created, so that we work with the account we wanted to work with. That is the account wallet. So that is basically the change I've just made, guys. I hope that never confused you. So we still don't have the account, so I won't delete anything, but I'm going to go ahead and create it. Let's see what this is going to give us. Yeah, so this seems to be working now. Awesome. Great. So that was done successfully. And now we can go ahead and perform our call. So I'm going to do get address info. The parameter we need at this point is going to be MSG. And this can just be any random message, okay? Just give that random message. Then I'm going to sign this particular transaction using our signer. So again, if I can minimize this, using our signer over there, and the signer is going to be that. Great. So we have all that in place. I just want us to go ahead and try and invoke these call scripts and see if it is going to run successfully. So let's see what is going to be displayed in our terminal. Yeah, so you realize we have accounts, and accounts, this was basically a new line, and it's doing a signer address is this, then predecessor address is that, then the caller message is that. Now I'll just go ahead and make those changes within my file. So instead of having it in one line, I'll just go ahead and add these line breaks. So we have accounts, then this and that. Then before predecessor, we just want to do a new line so that we capture that also in a new line. And these should as well be captured in a new line. Great. That is basically what you're going to do, the change you're going to make. So let's go ahead and try to build again, deploy. Oh, now in our deploy, we need to delete that. So I'll just repeat that again. Just repeat that once again. Okay, then you're going to try and call this now. Good, so you realize that it's trying to display everything in its own line. Now we have accounts as sort of the heading, then signer address is that, predecessor address is that, and the caller message is that. Great. So that is basically what you wanted to establish in these with this other smart contract, a very simple function that we're going to call from our other smart contract. Okay. Now I'm going to take us through something else. Great. I hope you can see my screen, guys. So before we head on to cross contract calls, let's do something on yeah, here. So promises. Now, promises are usually if you're coming from JavaScript, promises are usually intended to run. It's like you're trying to do an operation, but then you don't want the operation to block execution of other lines of code within your program, right? So the promises are run sort of asynchronously. Okay, so they don't block the flow or the execution of your program. They are run asynchronously, and once they are ready or their results is ready, you can always retrieve the results using the what? The .then method in JavaScript, that is. Now, usually you can as well pass a callback function to these .then functions, or to your promise in this case, right? So your callback function is basically intended to handle what? The response within your promise. Now, the same concept has been brought in the NEAR protocol blockchain, and there's a module in the Rust, in the NEAR SDK. In this case, what we are using in our Rust source codes. And that is what you saw as promises in the first source code I just showed us earlier yesterday, actually. So the promise module is basically helping us now in the NEAR protocol blockchain by running asynchronously means that your transaction or whatever you're going to enclose in the promise module will be run in a different block, or it will be run in the future. Okay, so let's say if you're doing an operation in the current block, and you have somewhere within your smart contract making use of promise to achieve any functionality, whatever sort, then it means that that transaction is going to be executed in a different block, or you intend that particular transaction to be executed in a different block. And so the execution is in the future. But still, there's a way you can be able to handle the response within your smart contract in the current block you're working on. So the two concepts is what constitutes the idea of cross contract calls, and we're going to see how that is going to unveil. But maybe just before I move there, promise comes in handy in performing other operations within the NEAR protocol blockchain. Now, yesterday we saw how we can use promise or the promise module to send NEAR tokens from one account to the other, right? We can as well use the same module to create sub accounts. So you see the way we've been creating accounts in our, through the sub accounts, that is through the terminal. The same functionality can be achieved in your smart contract. So you can basically have a smart contract that creates its own sub accounts. Okay, that is very possible using these module. So I've just clicked under promises. I've just clicked on creating accounts, and this is how we do it. You use the promise module, invoke the new function, pass in the address of your sub account. Okay. Then after passing in the address of your sub account and changing it to the right type, you invoke the create account method from that. So the create account is basically going to create that sub account, and the sub account is going to be a sub account of your smart contract. So in this case, the master account is going to be that of your smart contract, then the sub account. Then you right here, it is adding a full access key, right, using the signer's account public key, and it is transferring 0.25 near or 2.5 to power that Yocto near. So this is basically how you can create a sub account from your smart contract now. Then you can as well use this particular module to also perform deployment of your smart contracts. Okay, so imagine you have a platform. I don't know if this can be done or someone can think around it and come up with a project. But then guys, maybe just by the way, before I proceed, we also incubate projects at Sanctuary. So if you're having an idea you feel that needs some incubation, or you have an idea but you don't have the right funds to, actualize it, you can as well reach out to us. We will be able to help you in actualizing your idea as long as it's something viable and can run on the near protocol blockchain. That aside, now coming back to our promises, you can use this module, the promise module, to deploy a smart contract from your smart contract. What do I mean? Usually in our code, for the smart contracts we've done before, when we want to redeploy a smart contract, that is after making some changes as developers from our end, when we want to redeploy, you've seen me delete the sub account, then create it again. Okay. Now that won't be possible in mainnet, because in mainnet, your smart contract could be having some real funds. So deleting it means you're disadvantaging the users of that particular smart contract. So there's a way you can use your smart contract to update itself. Okay. So instead of deleting the account and creating it again, there's a way you'll be able to implement so that you just need to send the source code. Okay. Just send the source code you want to update, or you want your smart contract to update to, and it is going to update itself on the blockchain. Now, something you need to remember is once your smart contract is on blockchain, it is immutable, or it is not possible for you to change it. And if you wanted to change it, if you redeploy, you're able to change it, but there's a catch. If you're going to make any change to the state of your smart contract, so let's say you made use of the persistent collections or your instance variable within the contract structure in your lib.rs, then you said you wanted to add another property while making the update. In that case, the update won't be successful. Why? Because you've interfered with the state of that smart contract on blockchain. So there's a way you are advised to go about that. I think it's captured somewhere right here. Upgrading contracts. Yes, right here. So under upgrading contracts, this link over here explains everything I'm talking about. You can just click on that from your end and see what is happening. So in that case, if you try to update and you've interfered with the state of the blockchain, the state of your smart contract, then that won't be possible. But if you still want the update to go through, even with the change of the state of your contract object, there's a way you can go about it. And that is well captured under the link I've just showed us right here. So please follow that and see how you can do that. Then right here, I'm going to, so right here we are doing, this is how you deploy a smart contract from your smart contract, okay? So you can do a sub account. So in this case, you can create a sub account and deploy a smart contract to that particular sub account. So this is how you do it. You first of all use your promise module, definitely. Invoke the new function, passing the sub account wallet address that you want to create. Invoke the create function to create the sub account. Give it some full access key using the signer's account public key that way. Then transfer some tokens to it. These are 3 nears. Then invoke the deploy contract method and then pass in your code. So this is the source code, okay? The WebAssembly bytecode, what we've been deploying on blockchain. That is what is captured right here. So once you pass that in, the sub account will be created. Then Trinia will be, no, it is going to have a full access key. Trinia tokens is going to be transferred to the sub account. Then a smart contract is going to be deployed to it immediately. Now, maybe just a catch, because I've had people ask this before. Once you create that particular smart contract using this process, your smart contract won't be able to control that sub account in any way, because it will now be an independent account or an independent smart contract on its own. Okay, so we can't, if you wanted to interact with it, unless you use the cross contract call for you to be able to interact with it. And that is the concept we're going to cover today. So let me just head on to the window we're going to work from. I hope this is it. Are we here? Yes, yeah, this is it. Now I said that the convention of doing this sort of changed. And so I've not tested these source code or this particular smart contract. So we're going to do all these right here. Let me just avail our RES folder. Then I'm going to bring in our favorite scripts directory as well. So we are working from here. I just brought that in. Let's have some changes in our settings. We're going now, this is going to be, let's call these cross contract call .c4 anchoring, right? I think that fits it. We'll go with that. So we'll build, we'll deploy, but first of all, we don't have the account existing, so we won't delete it just to avoid unnecessary errors. Then we're going to go ahead and change the name of this. Let's call it XCC for cross contract call. Then come to our deploy script and make the change right there as well. So that is well captured, great. Then I'll just head back to my lib.rs. Let me just close this for now. Great. So we are here in our lib.rs file. And I've also made some changes. Even though I've not given it a try, there's some code in place that we're basically going to make use of. Now, right here, I'm basically in line 14, that is, I'm trying to create a constant variable that is going to hold a gas value. And this gas value is what you're going to use while calling our callback function within our contract, okay? So this is going to be gas for callback function. The gas that we're going to use for our callback function. Then over here, just immediately under that line, that is line 17, we are having a new macro. I know this is new to us. So this macro ext contract is basically used to capture or to be able to bundle, yes, I think that is the right word, to bundle our trait into a module. Again, if I can take us just, let me just share this. Let me take us back to where we were right here. Great. Then I'm going to show, now we have, just before promise, we have cross contract calls, then the callbacks. Now, everything we're going to do, you can read more from this link. So I was saying that this ext contract macro is going to generate a module from this particular trait we've provided down here, okay? And the module is going to generate, it is going to take the name ext accounts contract. Now you can name this anything you want. You can give it any name, okay? That should still be good to go. I just decided to name it ext accounts contract. So this macro will help us realize an ext accounts contract module, making use of this trait down here. And how is it going to make use of this trait? It is going to create a function. So in that module, you're going to have a function. This function is going to take the name get address info. Okay, so all these are going to happen behind. I'm actually explaining a high level view of handling cross contract call. Now we have low level, we have middle level, we have high level. What I'm apparently taking you guys through is a high level, but we have a low level. So while I was starting this, it's sort of the high level sort of gave me some headache. So I preferred starting with the low level, then to the medium level, and then that is when I got to understand this high level methodology. Now, our ext accounts contract module is going to contain a function by the name get address info. This function is basically going to accept a message string, sorry, a message parameter, okay, MSG of type string parameter. So it is going to bundle this function on our behalf such that there are other parameters that are going to be added. Now, initially, because I said things have changed, they've made some improvement on how you do this. But initially, we used to specify the gas that your function is likely to spend, attached deposit and all that, and the account address. But it seems that all that has been captured differently. So most of these are abstracted from you as a developer if you're using the high level way. Now, right here, I'm simply defining our structure. You realize it's empty, so it doesn't have any property. Then right here, I'm also just giving it default initialization. So I think you're familiar with that. Then down here, where we implement our contract structure, these are we are having some functions. I have apparently 3 functions that we're going to make use of within our smart contract. They are all, no, 2 of them are, actually 1 is public, okay? One is public, only 1 function right here is public. Now I said, sorry, methods are by default private within their structure, okay? And something you need to note is, there's another macro we are making use of right here, the private macro. So what is this really trying to achieve in place? Now, I hope you are familiar with this. So this is from Rust knowledge, the account ID function or method is default. Sorry, it's private by default. But then the response callback function, its signature indicates that it is public. However, this macro has been availed by the NIA SDK library or the NIA. And it is basically specifying that, hey, treat this function as a private function, okay? So although in its signature it is public, the NIA protocol blockchain will treat it as a private function while doing while invoking it within your smart contract, or while anyone is interacting with your smart contract. So we won't be able to call this particular function outside this smart contract. So the function will only be able to call is this call accounts contract. That is a public function. And this is what we're going to go through the very first. Our call accounts contract function is a method of this contract class. It's accepting the message parameter or the MSG of type string. and then it is returning a promise. I've just talked about promises, right? The promise module. Again, we are bringing this in from the near SDK. So don't forget that, guys. Okay. Then down here, take a keen look at this. Down here, we are doing the EXT accounts contract. Now I said up here, I said this is going to be the module that is going to be created using this trait. Okay. So the EXT accounts contract module has a method, or is going to have a method EXT. It's going to have a function, not a method. It's going to have a function EXT. And the EXT function is going to accept the address or the wallet address or the account ID where the smart contract you want to call lives in. So in this case, we're going to try to call a smart contract that lives in a different wallet address, right? Or that was deployed in a different wallet address. In this case, accounts.c4 sankore.testnet. That smart contract was deployed in a different wallet address or account ID from the one that these smart contract we are working on apparently is going to live. So inside the EXT, you pass the wallet address of the smart contract you want to call from your smart contract. Okay. So that is what we are doing here using the account ID method, and the account ID method is down here. So we are basically passing in where we deployed our accounts smart contract. That was accounts.c4-sankore.testnet. So this is the wallet address where we deployed it. And I'm basically capturing that and changing that into an account ID data type. Then I'm returning it. I'm returning the account ID value that way. So that is basically what that function is doing. So that is the value that is going to be injected right here. Then I invoke a method. So in our module, we're going to have a method, like I said, called getAddressInfo. So the getAddressInfo is going to accept a parameter, what we've just indicated up here. So it's going to accept the message string parameter. That is what we are basically passing there. And this message string parameter is coming from whoever is invoking this function. Okay, so it's coming into the call accounts contract method as a parameter, and then we're just passing it down into this function as it is. Now, let's first of all not talk about this for now. So I first of all want us to give this a shot and see how things are unfolding. Okay, so up to this point, we are returning. Now, this is going to create a promise behind the scenes. This particular statement is going to create a promise. Okay, hope that is quite clear. So this is going to create a promise. Then we're basically going to return, or our return type is going to be a promise. So whatever is going to be the end value of the whole of this execution is what we're going to return, and we expect that to be of type promise. Now, I just want us to go ahead and deploy this. Okay. So again, I'll just bring in our script files. I don't know if we changed. Yes, we made the change. Our build is good to go, and our deploy as well. So I'll just fire up my terminal. Let's first of all, let me give the right permission to my script files. Great. Then from there, I'm going to invoke the build script. The build script, we hope that is going to build successfully. Let's see. So let's hope that runs successfully. Maybe we could be working on our call script as wait for that. So we are here, and I'm going to hope I'm in the right file. Yeah. So we're going to, we have a signer right there. Then we have the test.getInfo in place. In this case, we're going to invoke the call accounts contract function of our smart contract right there. It is going to accept a parameter MSG. Great. So that is what we just did. So random message from, so this is going to be random message from our cross contract call smart contract. And I think the build was successful down here. So let's go ahead and deploy this. Let's go ahead and deploy these as well. We hope that is also going to be successful. Now, test. Right here we are testing the cross contract call functionality. Great. So let's wait and see what this is going to basically give us. If it gives us an error, then we're going to debug it quickly right here, because I said I've not done this. I've not done this before. I've not directed the changes. So let's try and call. So let's make the call and see what is going to be returned back to us. Okay. Great. So that one just worked, guys. Okay. I was expecting to meet some very some root bugs right here, but then everything went successfully. So you realize, guys, that we are now invoking. Okay, the response we've just received is similar to what we got while invoking the get account or the get, it was get address, right? While we were invoking the get, let me just get the right function, the get address info, yeah, method of our account smart contract. Okay. So now this time round, we are invoking this from our XCC sub account of c4-sankore.testnet wallet address. So how comes that we're getting the response? We are back to our source code right here. So in this case, we are invoking the get address info method or function of the account's smart contract through a cross contract call. And how have we been able to achieve that? Through this statement. So ext accounts contract, passing in the or specifying the address where the second smart contract lives, then invoking the function of that particular smart contract that you wanted to call. And now, back to our signer and predecessor. Now, it is very well captured right here. I don't know if you can be able to see this now. So we had the signer, again, if I can just head back to my call script right here. So we had the signer as paul.otieno.testnet, right? So this is the wallet address that initiated this transaction. And that is what has been captured right here, okay? Then the predecessor is the immediate wallet address that initiated the transaction in a smart contract. So the immediate wallet address that initiated transaction in the accounts.c4-sankore.testnet, where we deployed our first contract, was xcc.c4-sankore.testnet. So this was the predecessor address, or the address where our cross contract called smart contract lives. Okay, so we had I don't know if I'll be able to capture this right here. I really hope that this is going to sync. So we had the signer wallet initiating a transaction in our cross contract wallet. or our cross contract smart contract. Then our cross contract smart contract initiated another call to our accounts smart contract. Let me call this contract, and these are the one as well. Contract. Great. So we had our signer wallet address initiate a transaction in the cross contract in our cross contract smart contract. Then our cross contract smart contract initiated another call to the account's smart contract. Now our account smart contract was basically returning or responding in the function get address info with the signer's wallet address and the predecessor's wallet address. And now, when we invoked the function, maybe if I can as well share these, I hope I'll be able to get these right here. Great. So we are back in our account smart contract. So if I go ahead and invoke the response is still here. So you realize when we invoked it, the signer and the predecessor wallet address contained the same value, or their value was similar. Why? Because the signer and the immediate wallet address that invoked a transaction within the smart contract was basically equal. But this time round, within our cross contract called smart contract, now it is returning. Let me capture this return type using that. So this time around, it is returning the signer. So the signer is going to take the value of the signer wallet address right there. So that is the first wallet address that initiated this transaction, right? Then the predecessor wallet address is going to be the immediate wallet address that initiated a transaction in this smart contract. So, and that was the XCC wallet. Okay. So you see, the wallet address that is going to initiate this call or this transaction in cross-contract smart contract. In the cross-contract call smart contract, that is in our call script was this wallet address right here. So this was the signer, okay? Or whoever is going to initiate this transaction. By initiating, I mean the person that is going to start that transaction, okay? That is going to be the signer. Now, the wallet address, the immediate wallet address that is going to sign transaction in our second smart contract. So we have two smart contracts in this case, the first one and the second, okay? So the wallet address that is going to initiate the transaction in our second smart contract, the immediate wallet address going to initiate transaction in our second smart contract, is what is going to be captured as the predecessor wallet address. Okay, so in this case, it is going to be the account ID where our cross-contract smart contract was deployed. In this case, it is xcc.c4-sankore.testnet right there. But the signer was Paul Otieno.testnet. So this was the person who started this transaction. However, in the process of transacting, the smart contract made another call to the second smart contract. And that was in this address. Okay. So I really hope you guys you're going to get this maybe as you proceed. Let me just cover the last item, right? Sorry. The last item we want to cover right here. And that is the callback. Now, just like in JavaScript, you have your promise, right? You're doing promise dot, usually in JavaScript, it's is it promise.new, I think. Not so sure. But you do promise that something, then you put whatever you're going to execute asynchronously, then whenever the response is ready, you pass a callback function to basically capture the response. Again, we'll be seeing how to do that when we go through the front end bit of this course. Now, whatever you're going to cover next is is how we handle callbacks or responses, okay, in our smart contract. Okay, so really take note of this message down here. This one is it ends with a caller message, a random message from the smart contract. Okay, so what we're going to do next is, instead of displaying this information to the caller, we're going to be able to handle it within our smart contract. Okay, so we're going to basically provide a function, a callback function, that is going to handle the response from our promise. Okay, so let's first of all go through the callback function. Down here, what has the private macro, the response callback, that is the function. And then I'll just minimize this for now. Good. Now, in our response function, there's another macro we are making use of, and that is these callback. Let me just get that right. I think there was also a change on that. So it should be callback and wrap right here. So these should be callback and wrap. Now we're using this callback and wrap macro, which is going to help us process our response into the right type we expect it to be. Okay, that is basically what that macro is trying to help us do there. So once our promise responds or gives some results, that result or that response is going to be captured in this response parameter of our callback function. And in our case, depending with the function we are calling in the other smart contract, we expect the response to be of type string. That's why we have that specified right there. Then within our body, or within the body of our response callback function, we want to process this response further. Okay, so this is basically giving us a guideline on how we can process the response within our smart contracts. But if you wanted to, that is, we have the response coming in. We are creating another string out of that particular response. This time around, the string is mutable, and we named it result. Then we're basically pushing another string to the response string, indicating that this was basically processed or further processed within our cross contract called smart contract. Okay, so we're basically adding this string from accounts smart contract. Now let me change this to something that is going to help us identify. So we can do processed. One is processed in cross contract smart contract. Yeah, great. So something like that. So this is basically going to indicate that the response from the promise was received, but then it was further processed before the result was displayed to the user or the first caller. So that is basically what we are doing here, and we are returning the result variable in our callback function. Now let's see how we're going to invoke the response callback function, or we're going to handle the response, our promise response. So up here, we had the statement up to this point. So that is what we initially covered. But then down here, we are adding, or we are handling the response using the dot then or the then function. Okay. So using the then function, we pass in our callback function as follows. We use self. Now self is a keyword. So this is basically indicating our smart contracts object. So self double colon ext. And again, inside ext, like I said before, you specify the wallet address of the smart contract you intend to do what? To call. So in this case, we are not calling an external smart contract, but we are calling our smart contract. Okay. So this question came up yesterday or in our session yesterday. Is it possible that a smart contract can sign its own transaction? So that is basically what we are trying to do right here. So instead of passing a different account ID, we give it we are passing or we are getting the smart contracts account ID using the current account ID function. Again, we covered these previously, guys. So this is basically going to return with the value of the wallet address where the smart contract lives, right? So this is going to help us get the wallet address of our smart contract, and that is what we are passing right there. Then we are specifying the gas that we want to attach to this particular transaction. Now, like I said before, the gas is what is going to sort of, propel the execution of these processes we've indicated in our function. So if you're going to attach something less, then it means they may not be able to execute. If we attach the right gas, right, then that will definitely execute successfully. So this function right here with static gas is basically specifying the amount of gas we want to attach to this particular transaction. And that has been captured in the variable xcc underscore gas, which I think we began with up here in line 15. So the xcc gas is basically containing, or we're basically giving it 7 teragas with not 4, but these are 12, yeah, with 12 zeros. So 12 zeros, that will be 7 teragas, 70 teragas. Then after specifying the amount of gas we want to attach, then comes the name of our callback function. And in this case, the name of our callback function is response callback. So that is what we are specifying right there. So you realize it comes last. Okay. Now, these should be able to pass the response of our promise to our response callback function, this one here, as a parameter in the response parameter, that is, then we'll be able to handle it further or process it further within our callback function. And again, you realize I'm not terminating this statement. Why? Because I want to return what the final value after all these processes. I want to return the final value again as a promise. So this time round, I'll not be returning the value from the first promise, or I'll not be returning the value from the cross contract call, but I will accept the response from the second smart contract, process it further within my callback function, then return the result after processing it further within my smart contract. So I expect that the response that is going to come, or the response that we are going to get, is going to be a response with this string. Remember, this string was missing when we initially executed it in our terminal. Okay. So let's go ahead and build this again and see how this is basically going to work. So the build was successful. Then we'll just go ahead and now deploy. And this time around, I want to delete the account first before I deploy. So that is exactly what I'm doing right there. That was done deploying. Great. So now we want to go ahead, and again, let me just have this commented out. And again, we want to invoke our call accounts contract. Okay, so we're going to do that by calling our call script or executing our call script. And this time around, we expect a difference response if you're keen. So let's invoke that and see how this is going to work. That one worked quite well. So right here, we have the signer as Paul. We have the predecessor address as our smart contracts, our wallet address. Then we have the caller message, a random message from that. Then processed. You realize that we now have this other extension. So this was first processed in our cross-contract smart contract before it was returned. Initially, we didn't have this part in our result or in our response. Okay, so we didn't have that part, but now you realize that we have it added in. Why? Because it was this one was the response was handled within our callback function before it was actually returned to us. So that is how guys you can basically, or how you basically go about the cross contract calls in a high level perspective.